So digital transformation means a lot of things to a lot of people. And I think the definition actually has changed quite a bit over the last few years. And for me, what it means is it's really a pervasive concept of transforming the way a business looks at the market, its buyers, its customers, and really transcends all levels of the organization to essentially transform or change the way in which the businesses operate. In a lot of cases, the tools, techniques, technologies, procedures that sort of back up that business or that company. And industrial manufacturing and critical infrastructure, where we play, digital transformation is really about revisiting the entirety of the value chain that exists end to end, and making sure that the teams, the people, the tools, the techniques all sort of adapt to meet the future market needs. In our case, again, the world of manufacturing, the world of the energy markets. And so that's what digital transformation is about. It's about preparing ourselves for the future and changing all the things that are related to the businesses to meet those demands and changes. If we take it down a level to machine building and equipment manufacturers, for example, all elements of how you decide to design the next generation machinery, construct and build it, and then turn it over into operations is changing as a result of digital transformation. So what does that actually mean? It means that, first of all machine designs are built digital in this days. You will essentially simulate and model how this thing could behave based on certain outputs. That transitions into an actual design engineering environment, a CAD tool, where you actually create a model of the environment that you're using or the machine you're building. And then that digital twin, that digital definition, starts to make its way into the operations world, where the machine actually gets built and constructed, and then ultimately turned over to a customer who's going to use it to produce finished goods, do, I don't know, palletizers, case packers, whatever the machinery of choice is. I think the other piece is that digital twin continues on. So now the machine's producing finished goods, it's capturing telemetry and data, vibration, thermal, temperature, whatever it may be. That information needs to make its way ultimately not only to the customer, because they use that to help produce finished goods, but that information can make its way back to the machine builders to inform on future designs, to improve the machinery as you get real-time information about how it performs in the field. That can close the design simulation loop for machine builders. The other thing you can do is open up avenues of growth for machine builders and OEMs and equipment manufacturers to create new business models where you start to monitor and maintain the health and well-being of that machine on behalf of the customer. So those can become sort of value-added services. And in this case, the machine itself becomes a fully digitally defined, living, if I can use the term, a piece of equipment that continues this constant loop of design engineering and optimization. And no longer is you just building a machinery that you turn over to a customer. It becomes a collaboration between machine builder and customer to actually drive improvements to ultimately make and manufacture better products. Radical collaboration is about engaging the community at large in industrial manufacturing, critical infrastructure, to help solve these enormous problems we're all facing. The energy transition, the increasing demand for power, the need to manufacture goods at a rapid pace, distribute those in an interesting and sustainable way. So the entire value chain of producing finished goods and manufacturing things requires this idea of radical collaboration. And the radical really just means that it's going to take basically all elements of that value chain working together to achieve the demands of the future. Energy is the easy one. It's daunting. The amount of energy that we need to meet the demands of the future forecast is significant. At the same time, we're trying to decarbonize those things at the same time and create a more sustainable future for us. So that, again, becomes a confluence of things. The responsible use of resources, not only from the energy side, comes to, really I break it down into a number of, if I can use the term feedstocks, but water, air, steam, gas, electricity. These are all elements that, the resources. And in many cases, electricity, of course, is finite, it's expensive. And we just talk about the demand for it. So better managing that in a responsible way is top of mind for manufacturers and frankly anybody, should be anybody in the world today. Water is another one. In a lot of places in the world, water is it's a scarce resource. And so more effective use of the world's resources to manufacture finished goods, to operate infrastructure like even data centers that use a lot of electricity, need water for cooling. That's what we mean by responsible use of the world's resources is, yes, to achieve radical collaboration and transform the industry and the markets that we serve, we need to do that in a responsible, sustainable way. And the last point on that, the pillar on that, is advanced technologies. How can technology help us meet these objectives, if you like, or these goals? And technology has a huge role in that. On the radical collaboration side, we use technology to bring people together, to collaborate, to capture tribal knowledge, as we were talking about a bit earlier in the day. That is the expertise that's manifest in the workforce, the ever-aging, I would say, workforce. And how do we digitally capture that using technology, advanced technologies? Synthesize that captured information and make it available for another, for another generation, right? The newer, early careers generation that's going to take on the energy challenge and the manufacturing challenges. A lot of the other technologies that we talk about are enablers for this. So, enabling rapid collaboration is one thing, but using technologies like artificial intelligence, AI, and different permutations of that, like predictive and prescriptive analytics, to help better guide and inform the workforce, to better optimize machinery and productivity and throughput. Visualization technologies like augmented reality, virtual reality, 1D and 2D information can help us envision the manufacturing infrastructure world around us and better interact with it, in a sense. And I think the concept of all this being backed by big data, 1D, 2D, 3D information, process, production information, all sort of comes together, and we synthesize and use that data to derive all those different improvements. And so those are maybe the highlights for those key pillars that we talked about earlier. So there's a lot of talk about openness in general. Open systems, open standards, open source as far as code goes, and I would just say open collaboration amongst peer groups and sharing data and things like that. So this openness concept is quite a bit, and I think what's fueling that is a number of things. One is I just think there's a realization that to solve these problems, what we face as an industry and as a species, if I could use that phrase, it's going to take a community, all the great minds that we have. And so the way to kind of fuse together the great minds and intellect is through sharing and collaboration of ideas. So open exchanges of idea, exchanging information. In our world about machines and equipment, it's about exchanging information about performance of how machines perform. How do they consume electricity and water and steam and air and gas and the resources we talked about. So it's that open mindset of sharing that information, those systems and those sources amongst a broader peer group, we think will enable rapid acceleration and progress for the industry and for the markets that we serve, and hopefully leave the planet in a better place that we found it one day. I mean, certainly people look at open systems as being a cost-sensitive thing, but in the end, you still are going to pay for that technology in one way or another. But I don't think it's necessarily about a cost. The focus is really on innovation and results, and the best way to sort of make that happen is through open and collaborative approaches. But it doesn't mean you can't monetize those things as a manufacturer, as a producer, as a machine builder. So I think the openness is more about rapid innovation, exchanging data and ideas to help move things forward. But certainly cost comes up quite a bit, but I think cost is cost reduction is almost a benefit of implementing these practices in the long run. Is AI a standalone product or a thing, bolt-on? I think I don't think so. I think AI becomes infused in all the things that we do in everyday life, and in the industrial world. And thinking about machine building or equipment, if you think about the design process there, we'll infuse AI to help create better designs, better use of wiring systems and wiring dyes, better use of piping, better use of different materials, for example, because AI can sort of run scenarios and generate different sequences far faster than humans can. So it won't replace humans, it'll just become a tool to help designers and engineers build a better optimal configuration. So I think AI in that case is sort of infused in the design process. Same thing occurs in the construction process when you start to go procure materials and actually construct and build things. I think AI can also help there with managing schedules, looking at delays, looking at supplier managed challenges and such. And then on the operational side, AI also gets infused in the practices there to identify anomalies. Hey, this vibration pattern doesn't look normal, or hey, this heat profile doesn't look right, therefore you might have a problem with this machinery. Or begin to identify patterns of increased productivity. Like if we run these machines at this particular set of parameters, we know we can get better output. So I think AI becomes infused very much in all elements of life, and in our world, all elements of our software, infusing the AI technologies to help empower the employees and the people that use our software every day.